All right, hopefully you've had a chance to work out all four types of questions. This first one happens to be an equation with one variable. It also happens to be a quadratic because of the x squared. We solve quadratics by getting all the terms over to one side of the equal sign, and then we have three choices to choose to solve. We can use the quadratic formula, we could try to factor it using box and diamond to get two answers, or we could simply graph the left side and graph the right side with y1 and y2 equals and see where it crosses the x-axis. In this case, it crossed at -1 and 3. Therefore, our solutions were at -1 and 3. Now, for the rest of this video, pay attention to what's in pink. That's the whole point of this worksheet. That when you're working with equations with one variable, the type of answer or answers you're going to get are going to be just numbers. As soon as you start throwing in an equality in here, for example, like the next box, you're going to notice the only difference now is it changes it from an equal sign to a less than symbol. You still solve them like equations, so you go through and use one of these three methods, quadratic formula, factor, or graphing, get your answers, which are 3 and -1, but now they become the boundary points. Our solution will either come up to and sometimes include them, or not include them based on how the problem starts. This one has no line underneath it, meaning equal to, so we're not going to include it with an open circle. Had there been an equal sign, then you'd have solid dots. So in this case, since there's no line underneath, we're using open dots at -1 and 3, which are the boundary points. Then to decide if the answer goes between or on the outside the points is by testing 0. If I put a 0 in for x here and a 0 in for x here, I end up getting -7 is less than -4. That is a true statement. So where 0 is, that's where you're going to also put the arrows or the solution, which is between the points. Sometimes the 0 won't work and the arrows will go outward. But again, in this case here, they can also be written as an AND statement. Because when you put the number in the middle, it's true in both this statement here and also true in this statement right here. And this is how we write the answer as an inequality. So you can write it like this as a number line and also as an inequality. But like I said, sometimes the 0 does not work out. So for this example here real quick, if 0 didn't work out in the middle and the arrows go outward, it's considered an OR statement instead. So then we say the solutions over here are less than -5. So you say it like this, x less than or equal to -5. Sometimes the solutions are off to the right, like you see here. So I say x values that are greater than or equal to 10. That's an OR statement. The current one we have right now is an AND statement, and it's connected between. Moving on, if you have a system of equations that have equal signs, like you see here in the bottom left corner now, check this out. If you have problems like this, you're going to notice that you have to use coordinates to solve the solution. You can sometimes use substitution, like you see here, set the two equations equal to each other, solve for x. You find the matching y value by plugging your answer back in the problem to get the matching y value, which is the other half of the coordinate you're trying to find. Because when there's two variables, x and y, you have to have an x and y in your answer, which is displayed as a coordinate. So pay attention to what we have there for that as well. Then sometimes we move our systems not just to equations, but to inequalities like you see here. The only way you can show the solution to the system of inequalities is by showing a shaded region. Some things to consider how that shaded region is made. When you have a y greater than, like you see in the parabola here, you're going to shade above the graph. Here you have a y less than, so you're going to be less than or equal to, so you're going to shade below the graph. So we're going below the line and above the parabola. That overlapping shaded region is the shaded blue area that you see right here. You also will notice that the dotted versus solid. If you're going to have a dotted graph, it's because the graph is not included. There's no equal sign there. So we show that the graph is not included by making it dotted. If there happens to be an equal sign in the inequality of the graph, then we're going to make it solid like you see like here for the line. Okay? So we're doing a solid line shaded below and a dotted line shaded above. The only way you can show a solution to this problem here, or all the solutions, since there's infinite number, you have to show a shaded region. Quickly to summarize, when you have one equation and one variable, your answer is just numbers. If you have an inequality with one variable, you have a number line, sometimes listed as an AND statement, sometimes listed as an OR statement, depending on how the arrows go. This problem right here, again, if you have equations, two of them, a system of two equations with two variables, your answer is going to be coordinates. And last of all, inequalities is a shaded region. Hopefully this video helps, and hopefully you can be more successful with the types of questions you solve.